Okay, we're on our next video. We're rolling into equilateral triangles because our last one was isosceles, and what happened was we got 45-degree triangles and worked with our unit circles. So let's hop right to it. Down here below equilateral triangle, what do we know? We know that all three of these are congruent. All sides are congruent, also all three angles congruent. So shorthand that, three angles. All congruent. I guess I probably should spell the whole word out. Anyways, we know that the sides and angles are congruent. Below is a triangle that is not equilateral. How do we make it equilateral? It's a very unique case. What we're going to do is we're going to simply take and extend down. And basically what we're doing is we're mirroring this across, so that we're duplicating it in a very particular way. And by doing that, we have 30 degrees additional in corner A, angle A. C is 60 degrees, and this new one, I guess we'll have to call it D, is 60. So simply mirroring this triangle across its horizontal AB, we now have a 60-60-60 triangle, or an equilateral triangle. Now, the next thing it asks us to do is to assume, I hate to do that, but it does ask us to assume something. And that is simply that this side AC is 1. And then find all the other missing side lengths. Well, that's pretty easy, because when we flip that, then AD is also side length 1. And if all things are created equal here, then the overall side length CD is also 1 unit. So with that said, what I need to do is break that down so that BC is 1/2 and BD is 1/2. Well, now what we really are looking at is a triangle. If we look back to AC, so here's A, C, and B. That was 1 and that was 1/2. We figured that out pretty quickly by using that mirror method. So what we want to find is AB, side length AB. Well, we're going to use Pythagorean's theorem. So 1/2 squared plus x squared is equal to 1 squared. Okay. Then we rearrange everything. And when we do that, just to clarify, when you have a fraction like that squared, it's the same as, you can take that squared and distribute it to the top and the bottom. So what we have is x squared is equal to, really it's 1 minus 1/4, so that's 3/4, meaning that x is square root 3/4. Now the same thing happens here. Square root of a fraction can be rewritten where the square root symbol is applied to independently the top and the bottom. And square root of 3 remains square root of 3, but we know the square root of 4 is 2. So the side length AB is square root 3/2. So all very useful information. We have all three angles, 30, 60, 90, and we have all three side lengths, 1, 1/2, and square root 3/2. And when you look at that, the easiest way to remember that, in fact, let's draw this out. I'm going to use the bigger space here, but as you draw these triangles, you're going to want to remember a few things, like obviously hypotenuse is 1, because this is a unit circle. We always use that longest side is 1. But then even if you remember, one of the side lengths in a 30, 60, 90 is 1/2, and one of the side lengths is square root 3/2, you can do a quick memory check. Well, a smaller angle should go with a smaller side length. So smaller angle should project a smaller side length. Larger angle should project a larger side length. Well, we have two numbers to work with here. 1 over 2 and the square root of 3 over 2. Well, without knowing the exact value of the square root of 3, I know it's bigger than 1. So this fraction is bigger than 1/2. So that means that the square root 3 over 2 side length has to go with the larger angle 60. And when we do that, we're going to take that into our unit circle. I'm going to drop this guy down here. And that's square root 3 over 2, and that's 1/2. Therefore, this coordinate is the square root 3 over 2 in the x direction, comma, 1/2 in the y direction. And going back to that 45, 45, 90 triangle we worked with previously, we know that the x is the cosine, y is the sine. And again, let's look at that. Why is that? Well, if we look at sine of 30 degrees, in this particular case, sine of 30 degrees in the unit circle is 1/2 over 1. Or just 1/2. Cosine then cosine, again, that's adjacent over hypotenuse. So we get root 3 over 2 over 1, or just square root 3 over 2. And in the most general sense of the word, cosine and sine, where I put that cosine comma sine, that's the idea of this is your y term and this is your x term. So, sine of any angle is y over 1. So if we rewrite that, the y value is equal to sine. Same thing if we do cosine. Cosine of any angle theta is x over 1. We rewrite that for x. We get x is equal to cosine theta. And that's where we come up with the original x comma y there. So if we were to plot this in general algebraic expression, that's over x up y. We know that x is cosine, y is sine, so cosine and sine. And then if we go even further, specifically with 30 degrees, cosine of 30 degrees is square root 3 over 2. So that's where that term comes from. The y is sine theta. Well, sine of 30 is 1/2. Everything works out magically. So that's that. How many other triangles? There are 4 total. Sine, cosine, tangent of theta. That was 1/2 square root 3 over 2. Oh, let's do this really quickly. Tangent of 30. Tangent is opposite over adjacent. Well, opposite was 1/2. Adjacent square root 3 over 2. Okay, let's do that. So that is square root 3 over 2. Okay. So instead of doing 1/2 divided by the square root of 3 over 2, we can take 1/2 times the reciprocal, times 2 over the square root of 3. And what we get is the 2's reduce, and we get 1 over the square root of 3. So we can box that in. Or there is another answer we would accept, and that is if we were to multiply this by square root of 3 over the square root of 3. So we're really multiplying the answer by 1. But what happens is 1 times the square root of 3 becomes the square root of 3, but square root of 3 times the square root of 3 is just 3. So we would also accept the answer. It's the rationalized answer, square root of 3 over 3. There, that's all. Still under 10 minutes. Sorry about that. But we're going to end here on this video and move on to our last segment in 2-3.